what are its features, why should we learn Hadoop, and what is it, so that what makes Hadoop so hot, so that everybody is speaking about it. Well, this training is organized by BISP, Business Intelligence Solution Provider. They have we provide the software solutions and all the training throughout the world, US, UK, Canada, and everywhere. Well, this Hadoop is, we say it's a solution for big data. Now, we will just try to find out what is this big data? What is the problem with the big data and why we need a solution for it? Why are people so much interested in big data, its processing and all? When we see what is the source for the big data, we find it here that we have nowadays so many sensors which sense the data, which we need to look after and analyze and process them. There are so many devices, there are so many web applications, web servers. So these are all the sources for the big data. These applications, they generate a huge volume of data, and the volume, it increases from terabyte to petabyte and zettabyte, yottabyte, and so on. So there is a continuous and tremendous increase of the data volume which is coming from various sources. Now, see, but also the big data, it's not only the volume, it's also the variety. There are different types of sources like blogs, chat, images, video, system logs, web application logs. These are all the various sources from where we get a huge amount of in volume as well as in variety. So this leads to a big data problem. Now when we have so much of data to analyze, and so we definitely need a technology. Well, so why are business, from the business perspective, why are people so much interested in processing of the big data? They can do a lot of analytics. Let's some of the examples are like which reason should I increase my marketing? People can come to know that, okay, this area I'm not able to sell my product well, so I should market well in that area. This is only possible after we get lot of data and then we analyze it. Now, who are my top paying customers? We can analyze it from the after processing of a big amount of data, and how can I increase my customer loyalty? So these are the business insights which lead us to process big amount of data and come up with a solution. Now, but what is the technology demand? When our traditional system, they can cannot process this huge amount of data, and they are not such reliable. So what is the demand from the technology? The demand from the technology is it should be highly scalable and commodity hardware. Now, to process huge amount of data, we cannot keep on adding n number of servers every time, because if it goes from beyond yottabyte, then the servers will definitely be costly and it can't be afforded. So people need something which should be scalable, so they can increase incrementally according to the need base, and also it should be commodity hardware. When I say commodity hardware, it's the one which we use in our day-to-day life, like 4 GB RAM, 500 disks, 500 GB disks, so and normal processor. So this is commodity hardware. People want to use these hardware, rather than going for the servers. People need a distributed parallel processing. One big task can't be done by a single machine, so they wanted to distribute it among n number of parallel system, and the data can be processed parallelly. That kind of architecture is required from the technology perspective. ACID-free approach. ACID is a property which defines how reliable a database is. It's actually atomicity, consistent, isolation and durability, which these are the four properties which normal traditional database is required to have when we need a reliable data transaction and data processing. So people, in case of big data, people from the technology perspective, people wanted an acid-free approach. And so what is the solution? People needed MapReduce type of programming. We'll see what exactly it is. So why can't we use our same traditional storage? Like till now we have been using RDBMS throughout as a solution for data analysis and data storage. But there is some problem for analyzing the same traditional approach in case of big data. It comes, below are some few points, like traditional data storage, they need structured and clean data. Now when we load a table, when we load a data in an Oracle table, it has to be in a proper schema. We need to first define the schema, and then it will, like, we have to define what will be the different column properties, size and all. And our data should be clean accordingly. We have to clean the data before loading into the tables. So it is costly affair. We need, because the cleaning and all, it needs time. Well, when the data is used and the volume is high, then the storage to accommodate has to be scaled up. Now, when our existing server is not sufficient, in our traditional approach, we need to scale up by addition of a new server. So this is a constraint in the traditional storage. Now, when the use volume of data is there, then definitely we need more RAM to process it and to load a huge amount of data at a time. Similarly, processing power, also we need more processing power, because that all these constraints, they make servers really costly for processing big data. And finally, it leads to cost per compute as high. Now, cost per compute is for one computation how much I am putting. What is the cost? So this traditional approach, when we go for processing big data, then it will turn up to be very high. These are all the constraints for which people said, okay, this traditional feature, what all availability we have in the technology, it is not going to serve our purpose for big data. We need something more. We need something which should be unstructured. And then people came up with a solution which said not only SQL. So it should not be only structured. It should be non-structured as well. So that kind of data storage, we have a lot of not only SQL databases like Cassandra, Cloudera, MongoDB. All these are freely available in the market and they are very popular as well. Berkeley DB, which stores in key value pair, MongoDB for storage of the document. All these are very popular. But again, when we need to process it parallelly, then this type of database, they don't support parallel processing. So there was a need for a kind of hardware as well as a software which we can distribute, which we can scale up, and which we can parallelly process the data. So people came up with a solution, and they came up with Hadoop. Well, the fact about the data is 80% of the data available today, that is unstructured. And defining a structure is really a problem. And when we say we can only process 20% of the data, then 80% of the data goes waste. So people were very much interested in creation of a kind of technology which will serve their purpose both of unstructured as well as parallel processing. So there comes Hadoop. Well, it started, well, Doug Cutting is the founder of Hadoop. In the year 2002, he started with Mike and started working on the Nudge. Nudge is open source, it's an open source web search engine which Doug Cutting and Mike, they were working on in the year 2010 too. Now in 2003, Google published one paper which was based upon the Google file system and MapReduce, which was very impressive. And Doug Cutting, he thought to take the advantage of this MapReduce technology in his processing. So he utilized the MapReduce and made his web search engine very powerful at that time in the year 2004. Then Yahoo came and Yahoo hired Docutting. Yahoo, because of its huge volume, it also need to process terabytes of data for web search. So it actually had he hired Docutting and Nudge, which was the major priority project for Docutting. He came up, and also Hadoop was also a sub-project of Docutting, which he was working on at that time. Yahoo found this Hadoop very interesting and asked Docutting to do more research in Hadoop, because there were a lot of opportunity for Hadoop, which comes with parallel processing. So in the year 2008, Facebook launched one hype for SQL support for the Hadoop. It's like we can query on the big data and we can get the result, same as we get in case of SQL, normal SQL table. So same kind of architecture was developed by Facebook in the form of Hive. And in 2008, Yahoo made a record of fastest sort of a terabyte in 3.5 minutes. Yahoo put 910 nodes and they came up with this world record. The same record was beaten by Yahoo itself in 2009, and they sort the same 1 terabyte of data in 62 seconds by increasing the number of nodes. So this type of research was done on Hadoop, and it attracted a lot of eyeballs, and people were very much enthusiastic, because never before people have seen such technology and such fast processing, because the same amount of work would have taken weeks, but it was very fast in case of when it was done with the Hadoop. So, and there was a Hadoop summit in 2009, which was attended by 750 attendees, and this slide shows that the curiosity about the Hadoop, it increased from that time. In 2008, almost more than 200 people joined, and then there is exponential increase in the, there is more than 10 times growth in 5 years, and there are a lot of people joining this. This itself shows the popularity of Hadoop. In today's web, when we browse, and almost all the pages will find about big data analytics, Hive, Big, Hadoop. This shows how popular this Hadoop is becoming nowadays. Well, in the last 5 years, all the big companies like Yahoo, Facebook, eBay, Apple, Twitter, Amazon, all these people have contributed to this Hadoop project. And finally, we have reached to 2013, where we have a almost stable Hadoop, we can say, for enterprise. This Hadoop is accepted throughout as the enterprise solution, and the one which is set as a benchmark for big data processing. Now, what is Hadoop? We'll try to see like what makes a difference in case of Hadoop. Well, it's a software platform which can run on various with very n number of machines, and it can process vast amount of data. There are two major components of Hadoop. The first one is MapReduce, second is HDFS, which stands for Hadoop Distributed File System. Now, when we say two components, so HDFS is suppose all the hardware platform, hardware part, and MapReduce is what the software part of the Hadoop. What some of the features of Hadoop is it is scalable. Now, when I say scalable, it involves the use of traditional commodity hardware. So if today I need to process 1 terabyte of data, and I can do it by 10 nodes, and tomorrow I need to process 3 bytes, then I can scale up my number of the nodes and I can process it in the same number of time. So this is what scalability is. So Hadoop makes it, Hadoop is scalable. It is economical because the hardware, that is very cheap. as compared to the traditional servers which we are using. So it is economical. Efficient, well, why it is efficient is because the data, Hadoop has its own intelligence that it will process the data which is locally available. So when my data is available locally, it will send the computation and it will process it. If it is not available locally, then it will go to the nearest location. So it is efficient in case of parallel processing lot of data at a time and at a very fast speed. It is reliable. Now, this point is very interesting that we say we are using commodity hardware for the processing of Hadoop, and still it is reliable, because some might question that commodity hardwares are error prone, they can fail. Then how is Hadoop reliable? It's because it maintains multiple copies of the data, which is distributed among across the cluster. So we'll come to know this later, how it does it and all. So it is reliable. What does it do? It is based upon a very simple logic that and very simple ideology that if a big amount of work can't be done by a single person, so let us distribute it among n number of people and get it done at a very short period of time. Hadoop also does the same. Well, it is inspired by the Google's MapReduce, and it is using Hadoop distributed file system, which is also inspired by Google's file system. When MapReduce, it divides application into small blocks of work. Now, each small of work is assigned to like the work is divided into a small group and it is shared across the cluster to be processed. Now, output is assembled and it is given to the output. So it is as simple as that. Now, HDFS creates multiple replica of the data block. Why? Because to ensure the reliability. Well, if suppose by default it creates 3 copies. So if one data, we give one input file. So by default Hadoop will create 3 copies and it will distribute across the cluster. Now at a time, it is very we can say that 3 nodes, all the 3 nodes having the data will pass at a time. Even if it does so, then we have option to configure it to 5, 10 based upon how sensitive the data is. And as soon as one node fails and number of copies gets less than the replication factor, automatically on background process creates another copy. So this ensures that whatever data we are about to process, it's very reliable, and that also makes Hadoop very powerful and self-healing as well. Well, now once the data is available, then MapReduce small program can process the small chunk of data and can give the output. Well, Hadoop targets is to run on a cluster of 10,000 nodes. Just imagine how fast the processing and how much of big data it can process. Well, but why? Okay, those features are fine, but why is it so that people are so much interested in Hadoop? Nowadays, people are moving from proprietary to open source. This Hadoop comes as an open source from Apache Foundation. Everybody, people are no more interested in proprietary software. They want open source. Well, this revolution is related, it started from Linux, and nowadays we find a lot of applications, lot of service is given as open source. So people mindset and enterprise are moving from Windows to Linux. And similarly, when in case of big data, when Oracle and all, they can't support, then people, they need to move upon open source, and Hadoop is a solution. We say Hadoop is flexible, scalable, flexible because we can increase the number of nodes, we can decrease the number of nodes based upon our requirement. Scalable, also same, almost in the same terms. Cost effective because yes, it is open source. Second thing is the hardware is cheap, and compute. Well, this is very interesting point, that compute and storage. Now this this solves the purpose of both compute and storage. Uh, it supports terabytes, petabytes of data. We can store it, and also we can parallelly process it. So both storage and computation problem is solved by the Hadoop. And okay, this is speed and its accuracy. The speed, the above example which I gave, it is very fast. Something which was taking a week of time can be done in minutes. So this shows how speed it is and how accurate. Cloud support for Hadoop. Well, two of the most talked is cloud computing and big data processing. So cloud also support Hadoop because in case of cloud, any enterprise can go to a cloud service provider. He can ask for any number of nodes. He can scale up and scale down, and just he has to pay the bill, the amount of nodes he used. So this cloud support for Hadoop also makes it very powerful for the enterprise who can't afford so much of hardware and can't invest so much of money in the buying servers and all. So this makes Hadoop really very powerful. Some of the assumption in case of Hadoop, we assume that the hardware will fail. Because hardware is very cheap, we assume it will fail. That's the reason why we have replication factor, so that even if it fails, the automatically copy will be kept in some other node. Processing will run in the batches. Now this Hadoop is it's for batch processing. Not till now it is not yet ready for the real-time processing. In case of Oracle data, Oracle tables, we can, because the data volume is small and it's structured, so we can get a real-time operation in case of Oracle. But in Hadoop, you just put the data and in the batch and just run it and then wait for the output. So it is best suited for the batch running. Well, we assume that all the applications which use Hadoop will be having a huge data set, maybe starting from terabytes to whatever. Well, data bandwidth. Now Hadoop provides very high data bandwidth, and we also need a very good bandwidth because there are so many number of nodes connected to a single cluster. So the bandwidth should be high, and application which need to write once and read many times. This is not yet good enough for write purpose. It is very well suited for the application which write the data, load the data once, and then read many times. There are many applications which do so, like when we need to analyze the logs, when we need to find out the call history in the case of telecom computer of the last 5 years, 10 years. In that case, we don't need to write the data every time, but we need to, for analytical purpose, we need to read many times, and for reporting purpose, it is very well suited. Well, the second thing, last thing is moving computation is cheaper than moving data. This is a very important point in case of Hadoop. In our traditional system, we move data towards the computation. Now, what does it mean? Now, let us say our application is on one server and data is stored in some other server. Now, our application will first connect to the data server. It will pick up the data and it will bring it locally, process it, and then use it. So this is what till now we have been doing in our old application. But in case of Hadoop, it is just the opposite. Because the data volume is big, we will not pull the data. We will move the computation logic, the application itself, closer to the data, where it can process the data and give the output. So this reduces the I/O time in fetching the data and getting it. So this is very effective, and this is cheaper as well. Well, Hadoop ecosystem is something we have. Hadoop distributed file system, which is the hardware part of Hadoop. On top of it, we have MapReduce, which deals with the software application and all the programming logic. And on top of it, we have ETL tools like Pig, Hive, and Scoop. Pig is again instead of writing the application, it's top level platform tool which automatically convert our queries into MapReduce and submit it to HDFS. Same for Hive. Hive is suited for SQL queries. The same way as we do the query in our SQL table, Hive is meant for querying on top of HDFS. And Scoop is for getting the data from our SQL into HDFS and from HDFS to SQL. So that kind of this is the Hadoop ecosystem. Well, components. The hardware part is HDFS, Hadoop Distributed File System, which is consist of one name node, and there are various other data nodes. Well, we can call it as a master and slave architecture as well, because one name node will be controlling all the data nodes. And on top of our hardware, we have MapReduce, which is the software part. It consists of a job tracker, and and there are many task tracker on each data node, and this job tracker controls all the task tracker. So it is it's almost, we can say, it's master slave kind of architecture in Hadoop. Well, MapReduce. We'll start with Map. We'll see what is MapReduce and what is HDFS in this demo as well. Worker failure. Now, we have so many nodes. We have thousands of nodes, and that node is assigned some work, and it failed. So what will happen to the assigned work? So this failure is automatically handled by Hadoop. Well, we have, in case of MapReduce, we have one job tracker which tracks the work of each and every task tracker. So each data node will have one task tracker. Even if any of the node fails and the task tracker is not able to respond to the job tracker, so that work will be assigned to another healthy node. It is as simple as that. Well, this makes sense because we have n number of data node or working node. Well, there even if it fails, it can be easily handled. But what if master itself fails? This is a very good question. Master node is the only one single point of failure for the Hadoop cluster. Well, master node, it has all the data where my data is stored and what kind of work each node is doing. Well, if it fails, then my entire cluster is gone. That is the belief. But to make it safe, till now there were many checkpoints. After each regular interval of time, the master node was keeping, like, it's just imaging and cloning its state in a file. So whenever it fails, it will recover from the previous saved checkpoint. Even if now people were not much interested, enterprise mostly were not much impressed with that way. So Hadoop from 2.0 new latest version of Hadoop, it comes with high availability. What it does, there will be two master nodes which will be always in sync, like it will be a RAID configuration. So even if one node fails, the another node will pick up and it will become master. So this makes Hadoop very robust and very self-healing as well. Well, in case of HDFS, whatever data we give, it is divided into small chunks. So if we have a file which is 128 megabytes, then it will be divided into two files, each of size 64 MB. Now, this minimum size or block size for HDFS is 64 MB. And now 128 megabyte of data is divided into 264 megabyte of small chunks. And by default replication factor of 3, it will be saved 3 copy each of 64 MB into across the cluster. So this is how the data is stored. And MapReduce will it will continuously, well, in case of it will be keeping track of the job tracker. If one fails, always the processing will be done from the locust available. If suppose data is available nearest, then the application will be launched on the nearest available data node. and we will process and output will get. If it is not available to the nearest on the same node, then it will process the data which is available adjacent node. Otherwise in the same rack. So this ensures that we always get the data as near as possible. And in case of any failure of a data node, automatically the work will be assigned to some another healthy node. Well, workflow is a client gives a work to the job tracker which is present in master node. Now job tracker job is to divide the work into small work and give it to each data node. So it will divide the work into different task tracker, and each task tracker will have one data node. So instead of work done by a single machine, it will be done by same work will be divided into small parts. It will be done by each data node. So data node is the one which do all the processing and storage of the data. Well, they communicate with the name node to for locating the data. Let us say application A, it needs to access file F. So where is this file available is all that information is available with the name node. So that application will check with name node where this data is available, it will process it. So this task generality, we got to know the picture that, well, a big task is granuled into smaller sections which is divided across the cluster, and it is completed, and finally we get the output at a very small period of time as compared to our traditional systems. Well, there is concept of mappers and reducer. Mapper and reducer, it's a part of MapReduce. MapReduce, it consists of mappers and reducers. So this combinedly makes it a MapReduce platform. Mappers, they generate they convert the input data into small key value pair. Many such key value pair are processed individually by each reducer, and finally we get the output. So every work which is done in Hadoop has to be done with the mappers and the reducers. Well, it's one example at Google. There are 2 lakhs mapper, 5,000 reducer, and 2,000 worker machine. So this is what powers the Google search engine. The first component was MapReduce. We got to know that how MapReduce works, how the task is divided into small parts, and how it is assigned to each data node, and how we get the output. Second part is HDFS, which is a hardware part of it. It is inspired by Google distributed file system. It is highly fault tolerant and low cost hardware. It is entirely deployed over low cost hardware, but still it is fault tolerant. Why? Because we have a replication factor which automatically takes care of the data, which ensures the data is there. Well, the disk size, the block size for HDFS, because it is designed to process huge amount of data, petabytes of data, so it is 64 MB is the default block size for HDFS. Well, whereas in case of traditional system, it is just 512 bytes. So this Hadoop is made to process big, and HDFS supports huge amount of data. It has very high throughput and very high 64 MB of block size. Architecture is it's very simple. We have one name node which contain address of all the data node and where the data is stored. So these are all the data nodes, and a particular file is divided into small chunks of 64 MB, and multiple copies is distributed across the cluster. So whenever a client will directly deal with a name node. Name node has its internal logic how it will distribute, and it will get the work done from the data node. So client from outside, you will be only communicating with a name node, and all the internal work will be done by the task tracker by each data node. in this case, let's say we have rec 1 and rec 2. Rec 1 has 3 nodes and rec 2 has 2 nodes. Well, the same copy is replicated. Well, we can have one copy here, we can have a copy here, and as well as in some other node. Now, when we have a copy here and a task comes, the job tracker will try to assign the work as close as possible. So, when we have data here, it will try to assign the work, if this node is free, so it will try to assign the work to this node. This will process the data, it will give the output. If it is not available, if this node is free and data is not available, it will try to process the data which is available adjacent in the same node. So this ensures that we try to read data as near as possible, as local as possible, and this finally improves the performance. Well, the component of HDFS, we have one name node and secondary name node, which has to be a different system. But in case of Hadoop, starting from Hadoop 2.0, it will be HA. And then we have data node, we have job tracker, we have task tracker. This task tracker, many task tracker is controlled by job tracker, and many data node they are controlled by name node. This is the component. Well, this is what a picture of Hadoop. In this case, this is one rack, and there are many such nodes. These are each individual nodes. This is the picture of Hadoop, which has got around 25,000 Hadoop nodes. Well, then where can we use Hadoop? There are many use cases where we can use Hadoop. Well, let us take a few examples in social network analysis. Well, today almost all the companies, they are very much interested in social network analysis, because today Twitter generates 7 terabytes of data, Facebook generates 10 terabytes of data. People, they keep posting blogs. They say a lot. Whenever a new technology, a new product comes into market, people they write their sentiments in the social network. So these companies, they are very much interested in social network analysis. They capture all the data which is available for their product from different social networks, and they want to analyze, okay, what are the advantages of my product? What are the drawbacks? How can I improve? In case of fraud analysis, many insurance companies, they need to process huge amount of data just to know that whatever claim is made to them is not a fraud one. Well, clickstream systemization. Well, this is very interesting in our when we browse internet. Wherever we click on a home on a page, that is also monitored. So people, they store where are we clicking in a database, how we are going, what is our path. Let us say we are browsing something in Flipkart. We checked for a product. We didn't found it so interesting, and we went to Amazon and we purchased a product. So people will keep a track how we what are we doing in the net, where all we are clicking. Well, this product will say, okay, why is it that my customer didn't purchase a product from me, from eBay, and why it went to Amazon? So this kind of analysis, it deals with huge amount of data, and to process it, we need Hadoop. Well, some of practical use cases where Hadoop has provided the solution in case of data storage. In NetApp, take a few examples. NetApp, it installs net applications throughout its client, and it continuously sends that data to the server, saying that how the application is working, if it is ready or not. Well, this deals with storage of a huge amount of data. Sensors today, in case of railways, in case of automobiles, there are so many sensors attached to the device which ensure that how each part of that vehicle is, whether it's healthy or not, or there is some problem with the data or with any part of the vehicle. So all this information is gathered from the sensors and it is sent to the server, where we need huge amount of storage and also to process to find out, okay, if any problem, then we have to come up. So this kind of data storage problem is very well served by Hadoop. Financial services, they need insurance companies, banks, they need to deal with lot of fraud detection and data validation for their day-to-day processing. Its transaction. So Hadoop, they need a solution which can process huge amount of data at a very fast speed. So for financial services, Hadoop is very good. Very well, Hadoop has served very well. In case of healthcare, there are companies, insurance companies, which keep last 7 years of claims made by each of its customers. So to process and to get the report, they need to process huge amount of data. Well, NextBio Research, in case of research, this is NextBio's company, which is a lot of medical research and is analytically, it provides a platform for medical research which deals with huge amount of data. People also are interested to have one point of source for the patient's medical history, all its X-ray report, MRI report, and if he is going with a treatment, then what kind of medicine is given. All the reports it has to be, in case of healthcare, it has to be stored somewhere and has to be processed. So this deals with huge amount of data, and in case of Hadoop has served the healthcare segment as well. Telecom companies, it's mandatory for them to keep a track of each and every call record is made by their network. So since 2006, all the call made it's saved in telecom companies. Well, there are billions of calls made daily, and there are so many customers. So when these companies need to generate the reports of any particular customer or any particular call, then they need to traverse terabytes of data. So Hadoop serves them very well. In energy sector, there's a practical example. Vestas, it's a wind power plant generation company. So when it sets up a plant by investing millions of dollars, they need to analyze because this wind energy, it mostly depend upon the weather condition of that location, how my wind velocity will be, what is the temperature, precipitation. All these factor is very important for generating efficient energy. So this Vestas, when it tries to install a new power plant, it will have to, for each geographical location, it will have to get the information or weather data of that particular region of the last 20 years, analyze it properly, and predict how the weather condition will be for the next 20 years. Because the plant life is expected to be minimum 20 years. So this kind of processing needs huge amount of data, and this is well served by Hadoop. OPower, it's software service which deals with a lot of power sector companies. This OPower, it generates report for each individual. Now this company, it claims that okay, it will monitor how we are using at our household, how we are using our energy, and how can we efficiently use it, what way we can reduce it. So for each customer, they need to see their trend, see their behavior, how they are using, and how well they can optimize. And they also provide solutions. Okay, if you are using it like this, if you use it like this, you can save this much of energy, this much of cost. Well, this type of service is provided by OPower, which deals with huge amount of data processing for each customer. Social media analytics, I just talked about it. Lot of people, it's very interesting because people spend a lot of time in social network nowadays, in Facebook, Twitter, and it's a very good platform which emerging companies see as marketing their products. Right. So these are some of the practical use cases where various Hadoop vendors like IBM, Intel, they have provided solution to these practical use cases. Okay, that's I'm done with the demo part. If we have any queries, then please ask me.